Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion about trilateration by talking about how we actually know this distance, right? So in the previous video, we sort of took it for granted that the GPS unit in your car or your smartphone was talking to all of these satellites. It was getting information, and it was magically just knowing how far away it was and where the satellite was located to be able to perform this intersection process that we call trilateration to figure out where you are and track you as you move through and navigate your route. But how do we know this distance, right? Let's not just take that for granted. Let's talk about how we actually know what this distance is, okay? And so to do that, I want to just do a quick review of what we talked about in the video about the components of GPS, right? Where we had, right? We had the user, which was your smart device, and we had the space segment, right, which is all of the satellites that are orbiting in space. And that at the end of the day, what we had happening was we had this coded message. That was being passed from the space segment to the user segment that the user segment was using to do trilateration, right? But how do we know our distance from a satellite? Let alone, how do we know the position of the satellite to be able to put that spot in the center of the circle? Well, all of that information is inside of this coded message, right? So this coded message contains a ton of information because you also have to realize it's also communicating with a base station over here. So it's passing more stuff than we need to worry about. But for the sake of the things that we're going to focus on in terms of in terms of our discussion about what the user segment is caring about, the coded message contains really two things. The first thing it contains is the position of the satellite. Right, and this is based on its orbit, which we're not going to talk about satellite orbits, but all right, long story short, satellites in space, especially the types of satellites used for GPS, are in highly monitored, highly accurate in terms of the mathematical precision that we've calculated them to orbits. So they know where they are. They know where they are very accurately, and they're communicating that position to us via the coded message. So that's how we know where to put that circle, right? So the dot in the center of the circle, right? This is based on, wow, let's try that again. Based on position given by satellite. Right? It knows where it is, and it's telling us where it is. So if we go back to the trilateration diagram, right, that dot in the center, that's coming from it telling us where it is via that coded message. Okay, pretty straightforward, right? Of course, it should know where it is. But how do we know how far away we are from it? That comes from the second piece of information that the coded message gives us. And that second piece of information is it gives us the time the message was sent. Right? This thing knows, right? It's got a clock, internal clock. It says, hey, here's my position, and here's the time that I sent you that position. So we, as the user, are getting from the satellite the position that it's telling us, and we're getting the time that it was sent. Okay? So we, as the user, now have two things. We have the center of the circle, and we have the amount of time it took for the signal to go from that position to us. Okay, well, that's helpful, maybe. Well, it actually is helpful, because you have to remember another note that I made in that video, where I said that this coded message is electromagnetic radiation. And the reason that's important, right? Electromagnetic radiation, another term that you sometimes hear used for that is light, right? Light is a form of electromagnetic radiation. So, what do we know about electromagnetic radiation? Or what do we know about light? Well, we know, right, that light, I'm going to make a note of this in yellow, right? Light travels a constant speed in a vacuum, right? So think about this, right? We know how fast this signal is moving, right? It's moving at the speed of light. Right, which is approximately, right, 300 million meters per second. Right? So we know how fast the signal's moving. Right? It's a constant. Right? Which we'll denote as C. Right? We know when the message was sent, which we will denote as T. Well, actually, we'll denote it as T0, right? Because we know when the message was sent, right? The user, right, knows when the message was received. Right, which we'll call T1, right? So we know how fast the message is going, we know when it was sent, we know when it was received. And we also know where the satellite was when it sent the signal. So can we do anything with that? Well, think back to sort of basic physics, right? If you want to figure out, you're running a marathon, and you want to figure out how far you ran, right? Well, all you have to do, right, is multiply how fast you're running by how long you ran, right? That's a basic thing that you do in high school, right? We can apply that exact same concept here, right? The distance, or you'll often see it referred to as the range, right? The range, right? This is distance from satellite. Right, is equal to how fast that message was moving, right, which we already know to be c, right, the speed of light, times, right, well, how long was the message traveling? Well, it was traveling the time we received it, which is t1, minus, right, the time it was sent, t0. right? So the distance from the satellite is equal to speed times, right, when we received it minus when it was sent is the time spent traveling. Right? So at a very basic level, and we'll talk about some errors that feed into this equation, but at a very basic level, right, this is how your GPS knows the radius of that circle in trilateration, right? It knows when it got the message, it knows when the message was sent, it knows how fast the message was traveling. You can basic calculation here to calculate the distance. And then you have to remember we also have the position because that was also sent in the message. Okay? So hopefully this makes sense. The idea that we're getting all of the information that we need via this coded message. We can use some general knowledge about the fact that this message is a particular type of energy with a constant travel speed to figure out how far away we are from the satellite. Center that distance on the position to be able to get, if we scroll back up, right, these nice circles. So this distance here, right, this is measured by the speed of light times the time it took for the message to go from the satellite to the user. Okay? So hopefully that makes sense. And as always, if you have any questions, please reach out. Thank you.